right, we're going to look today at a different way to represent the ratios within a compound. This is something that's a lot of times probably more used for common people. So for example, if we were looking at fertilizers, it may mean very little to a farmer to know the chemical formula of what is in their fertilizer, but what does mean a lot to them is how much nitrogen they're getting out of it. And so they might compare fertilizers based on the percent composition. What percentage of this fertilizer is nitrogen? And so this is percent composition. It's still a ratio of how much is in there. It's just another way to represent it. And so finding percent composition is the same way you find most percents. And so let's say we were looking at what percent you got on a test. Your grade on a test is really just showing you the percentage of the questions you got correct on the test. And so you should know that you get that by taking the number of your correct points and divide it by the total number of points on the test, and you multiply that by 100. And that tells you what percent of the questions you got correct. And so we're going to do something, again, very similar to that, and this is called percent composition. And so when we're looking at your test, you take the part you got correct, divided by the total, or the whole. So a part divided by a whole times 100. And we're going to do that, again, for these elements. So we're going to take the mass of the element divided by the total compound. And so a part of our compound divided by the whole compound times 100, and that tells me the percent of my element in that compound. Again, this should follow the law of multiple proportions. So if this represents the ratio of each element within a compound, if I'm looking at the same compound, it should have the same percent composition, because again, they're just ratios, just expressed as a percentage. So let's look at this first problem on your homework. So table sugar is a compound known as sucrose. Sucrose is composed of the elements carbon, hydrogen, and oxygen. Analysis of a 20-gram sample of sucrose. So right here, this is the mass of your compound. It tells you you're dealing with sucrose and 20 grams of it. You get this from a bag of sugar, and you find that the sugar is 8.44 grams carbon, 1.30 grams hydrogen, and 10.6 grams oxygen. And so you did some sort of chemical test to find this breakdown right here. So first we want to just do something familiar to us, and we just want to represent this as the ratio. And so we want to know what's the mass of each element compared to the total mass of the sample. And so if we're looking at carbon, right here we know we have 8.44 grams of carbon divided by our 20 grams of sucrose. And so it's just 8.44 over 20. For hydrogen, it is 1.30 over 20. So we had 1.3 grams of hydrogen and 20 grams of sucrose. And then when we broke down the oxygen, we had 10.26 grams in the total 20 grams. So these again are just ratios, and they're pretty much just this first ratio of our percent composition equation. And so now we want to use those ratios to actually go ahead and then calculate the percent. And so we're just going to take these ratios, multiply them by 100, and that's going to tell me my percent composition. And so I can just take 8.44 divided by 20, multiply it by 100, and get my percentage. And so you can see that I have, for carbon, I have 42.2%. For hydrogen, I'm taking 1.30 divided by 20 times 100, and the percent composition is 6.5%. And for oxygen, I'm doing 10.26 divided by 20 times 100, and I see that I have for oxygen a 51.3%. So this is my percent composition for this sample. Again, this is the percent composition for sucrose, which means no matter what sucrose I'm looking at, it should have this percent composition. This is the ratio in which these elements combine. If I were to have more carbon and less oxygen, I would no longer have sucrose. I would have some completely different element or different compound. And so if I went and got sugar out of my back room and I broke it down, I should get this % composition because, again, it is still the same compound. It's still sucrose. And that's following that law of definite proportions. Every compound has its own specific ratio of elements. So you're just going to use this information and do the rest of your worksheet. The other ones don't make you break it down into the ratios and then the percentages. And so feel free to just go straight to the percentage, just doing this equation straight out. All right, I'll see you tomorrow. Bye.